Hello, Joe Shaw here, full stack engineer in the Incubation engineering department at GitLab. I'm looking into APM, application performance monitoring, and observability, and how we can create an observability APM platform for the GitLab DevOps platform itself. As a quick recap, what we're looking at is how we store various APM data sources inside ClickHouse. So we could use ClickHouse as a unified backend for the APM data. And we've had some good progress looking at that with metrics. And what we want to do is move on to looking at logs and how we can go about storing those. And we've found some decent articles in the past about how we might do that. From last time, we've merged in project and environment integration, whereby you can configure the Datadog agent, which is the only agent we're supporting at the moment, just for a case of simplicity. And you can configure this with a GitLab API key and a project ID, and optionally an environment ID, and it will authenticate and authorize those data sources. And then in our ClickHouse backend, we get the relevant project ID and optional environment ID stored. So then we can, when we're visualizing the data and the users say authenticated with a particular project or looking at a particular dashboard for a project, we can pull the data in based on the IDs. One of the last things we had to do for this merge request was just go through a bunch of testing with it. We have integration tests for it. We've got a lot of unit tests. I just wanted to do some manual testing just for sort of my own sanity to make sure things were working as expected. So here's a sort of test matrix that we've got here based on the validity of the API key and its role, whether the project exists is invalid or valid, whether the environment exists or is invalid or is empty, and what the expectation we should see in the API when the agent is talking to our gateway, whether we're getting things like 403s or whether we are seeing the data being stored in the ClickHouse database. So that's fine, so that's merged in. The next thing we found, while I was doing some upgrades, and I'd upgraded the dependencies of the Helm chart that we use locally for testing, because we test in Minikube locally with this project. I found that the newer versions of the Datadog agent actually enable compression by default, and I think in this one it's deflate compression using zlib, whereas you can also have gzip compression enabled. So I put a relatively quick fix in to handle that as well, and it also allows us to put the sort of, we missed out putting limits in the Datadog API specifies. So a 3.2 meg limit on normal non-compressed, 62 meg limit is imposed on the decompressed body size of compressed payloads. And a relatively simple set of changes there. I've got some tests for those. So that's merged in, and the agents work fine now with the compression enabled. So that's that done. So the main diversion we ended up taking was me having problems with my test environment, in that a lot of the stuff I've been doing with it, because I hadn't had time to fully automate things, was a lot of manual deployments via our Helm chart, tweaking things, testing things that way, and it was becoming quite slow to deal with. And when I noticed that when I'd torn down the ClickHouse database with replicas, when I tried to rebuild it, I just couldn't get it to work. So I realized that I really needed to put some effort into making this much more reproducible at this point. So that goes on to the merge request, which is pretty much ready to merge. Now I just need to do a little bit more testing, whereby we've got environment automation set up in a much better way. So we've got a Helm set up for the test environment that we override with some parts that are hidden in CI variables and things like that. And one of the key things this does is the migrations themselves no longer rely on a particular database to exist. So this is all sort of configuration driven now, which means that we can have one ClickHouse cluster, potentially multiple shards or replicas, and different databases for different environments, whereas before it was assuming sort of one database to connect to an APM database. So that makes it much more flexible, means we can have sort of temporary environments without creating whole new ClickHouse clusters, which is good. And we have a GKE Google Kubernetes engine deployment automated from the CI pipeline as well, which we didn't have before. I was doing that myself. So that's much better now. And we've wrapped up the migrate CLI that we were using. So we're using a pre-existing migration tool, Golang, I think it's called Go Migrate. And just to make it easier and make a lot of the settings shared, we've just wrapped that in our own CLI so that when we build like the ClickHouse DSNs, the connection strings, we can share them between the tools. And then it has a bunch of default settings. So I'll show you, there's quite a few changes were required there. One big change, as I mentioned, is that the migrations no longer create the database, which is good. The database is bootstrapped first before the migrations run. So, for example, here's the config map in the Helm deployment, which creates a database based on a configured value there, and that will run once the first replica is set up. Now, this caused a lot of problems. And was one of the key issues when I restarted or tore down the cluster and started again. Was previously when we'd had this in migrations, we had an on cluster statement here, which is a standard bit of ClickHouse SQL to say that you want to create the database on the cluster. The problem with using this and the Alternity ClickHouse client was that the replicas wouldn't come up because this statement was expecting another replica to exist before the cluster had been fully created. It took me a long time to realize that the ClickHouse operator would actually handle the replication of the table, of the database, as opposed to me having to do it. So that took me a while to debug. So that's a lot simpler now. And just to quickly show you, here's the test deployment job here. And it's very simple because we already have a Helm chart that we work with. We have a testenv override file that has a set of defaults for that environment and has the ClickHouse set up for that environment. There are no secrets in there or anything like that. It's all hidden. That's all pre-configured within the cluster. So there are just references to existing secrets. And we override a kubeconfig file with protected CI environment variables and things like the Google application credentials, and these are hidden in CI. So in theory, it's all nice and secure, and we can reuse this process for other deployment tiers. And it's linked to a test environment, and so on and so forth. So that's nice and simple. It's easy enough to reason about. So that was that. And the last thing I was going to do was just point out quite a nice article that I saw around ClickHouse materialized columns and some performance optimizations here on the post-hoc blog. And I've seen a lot of this stuff presented elsewhere, but it's just quite a nice blog wrapping it all up and looking into how you set up materialized columns and actually how you use ClickHouse flame graphs, which is a flame graph being a visualization I've used before when debugging things like Go programs, but I've never been able to or known about the utility within a database engine. So this is really nice. That would be very useful. And then the article goes into adding the materialized columns, and this is something I think would be very useful for us. With our metric schema, we'll likely want to add materialized columns for array headers that are being used frequently, for example. So yeah, I thought that was a nice article there. And that's it for me. I'm off next week, but I'll be looking more closely at logging then and the CLoki implementation, and potentially doing a bit of benchmarking with that. So that's it for me now. Thank you very much.